So here we're given this system of equations, and what we want to find is not the solutions themselves, but just how many of them there are. So luckily we're already given both equations, sort of like we're already given x equals something in terms of y and y equals something in terms of x, so it'll be super easy to do our substitution. And that's just what I want to start with. I just want to substitute it in and just kind of just see what we get. So I'm looking, and I think it's going to be easier to substitute this in for y, because otherwise, you have to substitute this into both of those x's, and that's going to be really messy. So let's just go ahead and substitute this in for y. So this equation will become x is equal to 2 times this whole thing, right? So 2 times 2x minus 3x plus 9, close parentheses, plus 5. So from here, I want to just go ahead and multiply it out, because again, we're down to one variable, so that's really convenient. So let's go ahead and multiply this out, get some kind of quadratic equation. And then it's going to be quadratic because we're about to multiply an x by an x, so it'll be x squared, right? So x is equal to 2 times 2x times x, 2x squared, 2x times 9, so plus 18x, negative 3 times x, so minus 3x, negative 3 times 9, negative 27, all plus 5. So now let's distribute this 2, so x is equal to 4x squared plus, what is that, 36x minus 6x minus 54, and then plus 5. You notice I removed my parentheses because we don't need them anymore, because it's not being this isn't being multiplied by anything. So now let's just combine our like terms. We get that x is equal to 4x squared plus 30x minus, so negative 54 plus 5 would be negative 49, right? So just minus 49. And now we have a quadratic. We like quadratics that are set equal to 0. So let's just go ahead and just subtract x on both sides to get all the x's on one side and to set it equal to 0. So 0 equals 4x squared minus 29x minus 49. All right, so we have our quadratic. I don't know how to factor that. If you divide every term by 4, you're going to get nasty fractions. And you probably don't want to put this into the quadratic formula just because, well, it's going to be really nasty. You have really big squared numbers. You don't want to go through that because this is the non-calculator section. So there is actually a tool you can use that happens to be part of the quadratic formula, your discriminant, right? So your discriminant is just equal to just the square root of b squared minus 4ac. Well, actually, technically, it's not even the square root. It's just b squared minus 4ac. So again, if this value turns out to be larger than 0, that means there are two solutions to this equation. If it turns out to be 0, that means there's 1. And if it turns out to be negative, then there are no real solutions. So let's just plug this in and see what we get. So it'll be equal to b squared, so negative 29 squared minus 4 times c, which is negative 49. And you don't actually have to do the multiplication there because you see that this squared number is going to be a positive number, and you see that this negative 4 times negative 49 is going to make this part positive. So this is just going to be some big old positive number, which means there are two solutions to this quadratic. So there are two values of, so x is going to equal something, comma something. Two values of x that work for this quadratic, and you would find the full solution by just plugging, one x back into here, find y, and plug the other x back into y and find that corresponding y. So you would get like 2x, like x1 comma y1, and then you get some second x2 comma y2. Luckily, you don't have to find those. All you have to know or answer for this problem is C, that there are going to be two solutions to this problem.